Good morning, everyone. Myself, Dr. Ritlas Rathore, and today we will discuss about the introduction to the voltage source inverter. So, in the previous classes, we learned about the DC converters, that is buck converter, boost converter. Buck was a step-down converter, that means the output voltage is always less than the input voltage. In the boost converter, we learned about that the output voltage is always greater than the boosted output. We are getting the boosted output in the boost converter. So output voltage that they are the step up converters. Okay. In today lecture we will discuss about the inverters. So the word inverter in the context of the power electronics denotes a class of power conversion circuit. That means it operates from a DC voltage source or DC current source and converts it into a AC voltage or current. So what the inverter does reverse what AC to DC converter does. Okay, just inverter. The basic definition is can be found is the inverter refers to a power electronic circuit that converts the power in DC form to AC form at required frequency in the voltage output. Simple DC to AC conversion in the inverter. For example, in our solar panels, you have installed a roof, you have installed some people installed solar panels in the rooftop. They store the solar panel stores the energy, collects the energy from the sun and stores in the battery powered, and battery is a DC. So finally we need an inverter to convert this DC into AC power for our household supply system. So there we can use the inverters. So basically there are two types of inverters. One is the voltage source inverter and another one is the current source inverter. In voltage source inverter we have a voltage source, and in current source inverter we have a current source. I hope you remember the Thevenin's and the Norton's theorem, just like that. So these are the two basic building blocks. One is the voltage source inverter. Here you have a voltage source at the input side, and in the current source inverter you have a current source at the input sides. Okay, so the voltage source inverter has a step DC voltage source, and is the DC voltage is limited of zero impedance at the inverter input terminal. Whereas the current source inverter, we have a variable current from a DC source that has a high impedance, just like the Thevenin and the Norton theorems. Okay. So now we will discuss about the single phase inverter, because our unit is discussing about this unit is discussed about the single phase inverter, and next unit is about the three phase inverter. And firstly we will discuss about the single phase inverter. Single phase inverter are further classified into two types, that is for half wave and the full wave inverter. In the half wave inverters, and so half wave inverters are basic building block for the full wave bridge rectifier bridge inverter. It consists of two switches, and each of its capacitor has a voltage equal to the VDC by 2. Means we are using our main supply voltage as in the voltage source supply or VDC is splitting. We are splitting this supply into two equivalent supplies, that using the capacitor equal value of the capacitor. Okay, so we are getting a half of supply in the input side, that is VDC by 2 and the VDC by 2. In addition, the switches complement each other. That means the configuration of the half-wave rectifier switches is like that. They must complement each other. Means the one is on, the other one is to be off. And full wave inverter, the inverter circuit converts the DC to AC. It achieves it by closing and opening the switches in the right sequence. It has four different operating stages which are based on the switching or close. So in today's lecture, we will discuss only about the half wave bridge inverter. So here we are taking a case of half wave single phase half wave inverter using RL load. Uh, Listen very carefully. I am using load RL. Okay, load can be R resistive load, RL load, or RLC load. Okay, in this example, I am taking a RL load. So here you can see that your main supply voltage, this VD is split into two equivalent divide by two configuration, using two equal values of the capacitor. This is these two equal having the equal value. So the voltage is splitting by VD by 2 and VD by 2. So this upper part and lower part are just the mirror image of each other. Okay, this one is the mirror image of each other. Here we are using this power MOSFET, the T1 and T2. You can use the thyristor also in some books. Instead of using this power MOSFET, thyristor circuit is used. In thyristor, you will get a instead of this gate signal, you have a gated triggered. Okay, gate triggering is gate triggered thyristor. Here you will find a gate terminal in that case of thyristor. Okay, so you can use either power MOSFET or thyristor. Both are the correct. Okay, the main thing is these two parts are just mirror to each other. Here I say this point is B, this point is A. For this upper circuit, this will be more positive, and for the lower circuit, this will be more positive. Okay, so these are the output waveform. How we get this output waveform, we will discuss little bit sometime. So uh, just for the half wave bridge inverter circuit, the center tap of the DC supply is used as one of the load terminal. As we discussed earlier, center tap is created by using two series connected equal valued capacitor across the DC supply, as we discussed earlier, so that our supply voltage is split into two parts, that is VD by 2 and VD by 2. So next, the DC rail voltage are thus the mean rail voltage means high to low, maximum to the minimum value is plus VD by 2 to the minus VD by 2 with respect to the some fixtures ground point. What is the meaning of fixtures ground potential? Let us assume that there is a ground, some ground potential is this terminal is connected to the ground, or we can say that this is a minus terminal. That means this is fictional fixtures ground potential. Okay, next. So here we can see that two switches T1 and T2, two power MOSFETs are T1 and T2 are switched alternatively. Means one is on, then another is off, and one is off and the other is on. When T1 is on, T2 is off, and the voltage terminal A of the load is plus V by 2. What is saying that whenever you give a positive gate signal to this terminal T1, what is happen? This will on, this will on, and this must be off at this time. So means the gate terminal of this switch must be 0. Okay, so when this is on, this upper part is working, this part is working, this is short circuited, this is short circuited, current will flow. This node is more positive with respect to the B, so this A is more positive with B. You will get a this supply VD by 2 will appear across the load. Okay, at this node VD by 2, because this is short, this is short, this VD by 2 will appear at this A point. Okay, and whenever this transistor is off, that means the transistor T2 is on, then a reverse operation is over. This will be more positive with respect to this, so this will get the value of minus VD by 2. Okay, so similarly when T2 is on, T1 is off, the potential point is minus VD by 2. So what the load voltage is square wave amplitude of VD by 2, means what we are saying that your output voltage will swing between the plus VD by 2 to the minus VD by 2, and the current will follow the exponential path. We will discuss in using when we discuss the this waveform part. For the resistor load, the current waveform follows the voltage waveform. For inductive load, the current waveform lags the voltage waveform by an angle which is approximately the load power factor angle. What does it mean? It means if we are using this instead of using RL load, if we are using only R resistive load, then the current and the voltage are in phase. Okay, are in phase. Output current and the voltage are in phase when using the R only. When you are using the inductive load, then current will be current will be lags. Current waveform lags the voltage waveform. Okay, that will decided by the angle, load power factor angle, known as the load power factor angle. Next is waveform. How we get the waveform? So first of all, just draw a simple waveform T1 and T2. When T1 is on, T2 is off. When T1 is off, T2 is on. Simple. Only these two waveforms are important, this first part and the second part. These are the remaining waveform you can draw there, but important part is T1, T2 and this output waveforms, output current and waveform. So whenever your transistor T1 is conducting, you will get output is plus Vd by 2. Okay, you are getting output of plus Vd by 2 when your transistor T1 is conducting. When your transistor is off, the voltage across the A is minus Vd by 2. So this is minus Vd by 2. Again your transistor T1 is conducting, you are getting the voltage plus Vd by 2. So here you are getting a perfectly squared wave at the output terminal, plus whose real value is plus Vd by 2 to minus Vd by 2. What we know about the current? In the current, because it's a RL load, if it is a simple resistor load, then it will follow the your output current will follow the output voltage. But in this is the RL load, that's why the load is storing the energy, L is storing the energy, inductor is storing the energy, so it will release during this path. So firstly it will get charge, then it will get discharge. So this is how you are getting RL current. Okay, current across the RL load. This is the current across the transistor T1 and current across the transistor T2. You can discuss this. And these diode D1 and D2, what is the working of these diodes? These are the damping diode or reactive diodes. Whenever your inductor is storing the energy, whenever inductor is stored the energy, inductor releases this energy using this diode D1 and D2. These diodes are used as a protection circuit. These diodes are used to protect the circuit, protect this half wave rectifier. Damping diodes known as the damping diode D1 and D2. So when the transistor, what's the working? When the switch T1 is off, the load current is at its positive peak, that is plus Vd by 2, and it will continue to flow the diode D2 back to the lower capacitor across the DC source. The conducting diode D2 will reverse bias the diode T2 until the load currents falls zero. Thereafter, the diode transistor T2 will be forward biased and negative current will stabilize in the load through T2. Similarly, the diode D1 conducts when T2 is switched off and T1 starts to conduct when the load current rises to zero. So diode D1 and D2 carry the current which are due to the trapped energy. That is what I told you earlier. The diode and D1 are carry the current which are due to the trapped energy in the load inductor. Consequently, these diodes are referred as the reactive feedback diode, which return the load reactive power back to the DC source. These diodes are also necessary to allow path for the current flow when transistor is off, thus protecting the switch against the over voltage that would be created by sudden turn of current of the load inductance. So these are the protection diode, reactive diode known as the. So that is all about the half wave inverter. So what we learned today, we learned that initially what is inverter? Inverter is a DC to AC converter. We convert the DC signals into AC signal. Two types of voltage source inverter, current source inverter. Voltage source you have a constant voltage source apply at the input side, and current source inverter you have a current source at the input side. We are discussing about the single phase rectifier, single phase inverter. Single phase inverter are of two types, one is half wave and the full wave. In the half wave you need a this supply voltage, you need a two capacitor, equal value capacitor. The input voltage is converted by equal Vd by 2, Vd by 2, and in this case we are using RL as a load circuit. RL as a load, you can use R also and RLC also. If you are using the R, then output voltage and output current will be in phase. And if you are using a this RLC or reactive circuit, then the output voltage are out of phase. Voltage and current are out of phase. Okay, and diode D1 and D2 are the protective circuit damp diode known as a damp diode. uh, Working is very easy. The T1 and T2 are the power MOSFETs, or you can use the thyristor also. So whenever your this thyristor for the T1, when the transistor T1 is conducting, when the gate pulse of T1 is high, then what will happen? Then your node A is more positive with respect to the B, and whenever your T2 is working, then T1 is off, then that time B2 node B is more positive with respect to A, so you are getting an output rail of minus Vd by 2, 2 plus Vd by 2. That is all about the working of this. You will get a perfectly squared output as a terminal. Okay guys, thank you for today. In next class we will discuss about the full bridge inverter.